So previously in our previous class, we talked a lot about the semiconductor diode, okay, and how it functions lah. But basically, if last week was a lot, okay, was a lot to take in. I think the most important thing is that we understand what is the purpose of a diode. Okay, that's number one. Purpose of a diode is to ensure that current flows in one direction only. And today we're going to see how the diode functions to convert the alternating current that comes into our plugs, okay, to become direct current, which charges your phone. One of the biggest uses okay, of the diode that we can think of is in the charging of your telephone, because the telephone, your battery there, okay, in order to charge it, the direct current must flow in, like cannot be going out, going in, going out. Otherwise, what kind of current is going to be? How are you going to charge your phone, right, if it's just changing directions all the time? So it has to only flow in one direction. Okay, but the problem is, our current from the plug, okay, where we put our plug into, always comes in as alternating current. After you transform, you step down, comes to our houses, it comes to us as alternating current. And sometimes the alternating current has very good uses, okay, but for the purposes of charging batteries, charging our phones, our laptops, okay, we need something else, not just to step down the voltage a lot more, but also to make sure that the voltage or the current only flows in one direction. Okay, and that's where the function of the diode comes in. Okay, so a diode is an electronic device, okay, or electronic component that allows the direction of the current to flow in one direction only. Okay, allows the current to flow in one direction only. And the way it does it is we look at how it is biased. Okay, is either forward bias or reverse bias. I know nowadays when I say the word bias, it means something else, thanks to the horrendous language of the millennials, the Gen Z or whatever. Okay, but when we talk about forward bias, okay, we talk about the the anode of the diode, okay, connected to the anode of the battery, and the cathode of the diode connected to the cathode of the battery. Okay, and this allows current to flow in this direction. Okay, but if we were to go in this way, okay, the current is going to flow here, but because it is connected reverse bias, okay, it's going to be stopped by the cathode over here. Okay, so there's no current flow over here, and therefore the bulb doesn't light up. Okay, so there are only two types of connections. When we talk about semiconductor diode, there's only two types of connections. You're either forward bias or you're reverse bias. If it is forward bias, current is going to flow very smoothly. But if it is reverse bias, current is going to be stopped from flowing. Okay, and we looked at the explanation last week. Why is it that current flows? We talked about a depletion layer and junction voltage and all those things. Okay, those are the technical aspects of it. But today, what we're going to do is we're going to look at the function. Okay, the function of the semiconductor diode and the capacitor in this application are called the rectifier. Okay, so these are words that we want to use today, especially the word rectifier. Okay, the word rectifier means to correct. Okay, untuk mengasih betul. Tapi dalam bahasa Melayu, rectifier is called rectifikasi lah. It's like, okay, fine. Rectifikasi, okay, tapi the meaning of the word rectify is to correct atau untuk ibarat kembali ke pangkuan jalan yang benar. Okay, so that's the word rectify The word rectify means to kasih betul, to correct, okay, to kembali ke jalan yang sebenar, okay, blah blah blah. Okay, so there's this, as I said just now, one of the uses of the semiconductor diode, okay, we can see it, especially in the electronics world, is when the smartphone, okay, or when your phone is being charged. It can only be charged with a direct current. Okay, that makes sense because you have a battery in there. Okay, so how does the semiconductor diode convert, okay, an alternating current to a direct current? Okay, we use this process called rectification. Okay, so rectification is the process of converting an alternating current into direct current. Okay, this is the simplest possible explanation. Okay, now there are two types of rectification. One is called a half wave rectification, and the other one is called a full wave rectification. And today we're going to look at exactly both of that. Okay, so now when we talk about rectification circuit, okay, this is the simple setup. Okay, you have a power supply, and then this is a diode as a rectifier kit okay, which I don't think we have this in school. Okay, but in short form, okay, in a simpler manner, you have a power supply that is supplying alternating current. Okay, it is supplying alternating current. Okay, because we want to make it look like our plug. Okay, and then we are going to put a diode over here, and then we're going to have the OSK over here, or the CRO. We saw the CRO a little bit in the first subtopic. A CRO is a device that displays the flow of electric current. Dia akan tunjuk arah lah. Okay, now because this is an alternating current, so the input of the alternating current signal will look like this. There will be positive regions and negative regions, positive regions, negative regions, positive regions, negative regions. Simply because the alternating current, sekejap sini positive, sekejap sini negative. So it's going to flow this way. Okay, but the next minute is going to be sini positive, sini negative, so it's going to flow this way. So the CRO, when it flows this way, it is this part at the bottom here. Okay, and then when it flows the other way, okay, it is this part up here. Okay, so the positive and negative shows you the direction of the current flow. But disebabkan dia naik turun bahkan, it also means that the current is increasing, decreasing, increasing, decreasing. Okay, so a very standard alternating current, okay, will have two directions and also varying amplitudes, varying current. Okay, dia akan makin meninggi current, makin menurun current, makin meninggi current, makin menurun current, makin besar, makin kecil, makin besar, makin kecil, makin besar, makin kecil. Except that this is in the negative region, which means that the direction of the current has flowed the other way. Now, let's consider this. If let's say this is positive and this is negative, okay, pada kitaran inilah, okay, pada kitaran ini, okay, is there going to be current flow or no?
Yes.
Why?
Because it's forward bias.
Because it is forward bias. Okay, the simplest explanation possible. You just have to think, they're forward bias or reverse bias. Okay, it's forward bias because this is the positive now, and it's going to be connected to the positive of the diode. So we expect to see this current. Okay, ini memang kita akan kelihatan. Now, what if we switch it the other way around? Okay, we expect to see this current. What if we switch it the other way around? This is positive and this is negative. So the current is going to flow here. Is the diode going to allow the current to flow through?
No.
Why no?
Reverse.
Okay, reverse what? Reverse kereta?
Reverse bias.
Okay, because it is reverse bias. Okay, keep the explanation simple. Okay, current flows if it's forward bias, current doesn't flow if it is reverse bias. Full stop. Okay, keep it simple. Don't say, oh, because of the current, that's that's last week's class, which is the long explanation. Okay, the depletion layer becomes bigger, blah, 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 blah. Okay, simple, keep it simple, reverse bias. Okay, so we don't expect to see this. Ini memang kita tidak akan kelihatan. Okay, so we know that if it is this cycle, ini akan nampak, tapi this cycle, ini tidak akan kelihatan, ini tidak akan kelihatan. Forward bias, reverse bias. So on the screen over here, what we are going to see is this output. Hanya yang forward bias saja dia akan nampak. Okay. Now, if I were to change this to a light bulb instead of a resistor kalau ini adalah satu mentol bahkan, okay, what would be the difference between this output and this output? Let's talk about this output first Okay, yang ini. Okay, what would the mentol be like? How would the bulb look like kalau begini dia punya current?
Kelip-kelip.
Okay, dia akan kelip-kelip, it will be on, off, on, off, on, off, dan seterusnya. It will be berkelip-kelip lah. Okay, and actually even when it is on, okay, dia akan bertukar dia punya current tau. Dia akan menaik dia punya current dan menurun dia punya current. Okay, that means even when it is kelip, but of course we see it's difficult for us to see lah. Okay, because our eyes is so limited lah. But in actual fact, it's going to be getting brighter and getting not so bright, and then totally off, and then getting brighter and then getting not so bright, and then off, and then getting brighter and then getting not so bright, and then totally off. Whereas on this case, okay, dia bukan berkelip-kelip, tetapi dia for us lah. Okay, for us dalam mata kasar, okay, it looks like it is continually on. Dia on saja. Okay, dia on saja, except that kalau kita perhatikan betul-betul, dia makin besar, makin kecil, makin besar, makin kecil, makin besar, makin kecil, makin besar, makin kecil. It sort of gets brighter and dimmer lah. But because this happens so fast, we can't see it with our mata kasar lah. If you put your camera in slow motion, you should be able to see. I mean, with more frames per second, you should be able to see that the light actually gets, there is a difference in the brightness lah. Okay, as more current flows, it's going to get brighter. As less current flows, it's going to get dimmer. And pada satu ketika, dia akan turn off sekejap. Okay, but because alternating current is, tapi ini, dia akan langsung off for a long time lah. Okay, so to us, this is going to look like it's going to be blinking. Okay, in English, berkelip-kelip is blinking, just like blink, blink, blink. Okay, this lah. Okay, so forward bias, reverse bias, forward bias, reverse bias, forward bias, reverse bias, begitu. Okay, wow. All right. So this is called a half-wave rectification circuit, and let's talk about why the output is produced as shown now. So in the first half cycle, this one, okay, the diode is forward bias, current can flow. Keep it simple. Okay, this is where it is. Okay, in this first half cycle yang di atas ini, the diode is forward bias and the current can flow. Tell me about how do I write in the second half cycle? Macam mana?
Reverse bias.
And?
Cannot flow.
Okay, so in the second half cycle, the diode is reverse bias. Okay, and the current cannot flow. Okay, keep the explanation simple. Jangan melibatkan, don't involve the depletion layer lah, the junction voltage, unless you are asked to do that. Okay, so I know that last week I talked a lot about depletion layer, and I'm like, oh my goodness, what a difficult explanation. Okay, but because we're talking about rectification circuit, okay, kita guna we use the right terms, and when we use the right terms, people will understand. Okay, unless the question tanya explain what happens when it is forward bias, then you have to talk about depletion layer lah, junction voltage lah, blah 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 blah. Okay, the holes and the electrons, yada yada, no need. Okay, for rectification, just keep it simple. Forward bias means current can flow, reverse bias means current cannot flow. So the function of the diode in the circuit, okay, is to convert the alternating current, okay, to direct current. Okay, in a rectification circuit, remember guys, if the question is, what is the function of a diode, full stop, okay, is to ensure that current flows in one direction only. But in the rectification circuit, dalam litar rektifikasi, the function of the diode is to convert the alternating current to direct current. Okay, so I want to just remind you that actually, compared to the first subtopic, this subtopic is actually very simple. You just have to keep things as simple as you can. Okay, function of the diode in a normal situation is allow current to flow one direction only. But in the rectification circuit, it converts alternating current to direct current because of that original function. Okay, it allows current to flow in one direction only. Yada 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 yada. Okay, so this is a half-wave rectification circuit. Why is it called half-wave compared to the next one, which is full wave? Okay, why is it called half wave? Because only this half, only this half, bodoh, correct lah, betul. Only this half, okay, only this half is rectified. Hanya yang ini saja yang yang dibenarkan mengalir. Okay, yang berlawanan arah, yang bawah ini tidak dibenarkan mengalir. That's why it's called a half wave rectification circuit. And just like we said just now, on a half wave rectification circuit, it's not so good lah, because if you put a menthol over there, it's going to be on off on off on off on off. After a while, your light bulb is going to mogok. It's going to say, semalas sekejap on, sekejap off, sekejap on, sekejap off. It's very tiring. Okay, have you ever? Yeah lah. It's like it's like, okay, Sir Marcus say go to lab, and then after that suddenly Sir Marcus say don't need, go back to class, and then after that go to lab, and then go to class, go back. Can you imagine in 1 hour, you just go back and forth from the lab to the class, from the lab to the class, from the lab to the class. You also will feel tired, right? So the same thing with light bulbs. Okay, on off on off on off. It's going to be very tiring, and it's not good lah. It's not good for the light bulb. So last kan dia akan mogok, then dia just terus, dah malas sudah. Okay, I'm just going to turn off. Okay, so because of that, we need to do something over this circuit so that it is always on, but direct current. Okay, the problem is this is on, but it is alternating current. Saya tidak mau. I want direct current to flow. So I need to make sure that this bottom half becomes like this. Okay, and that's why we have the full wave rectification circuit. Now, the full wave rectification circuit is an easy circuit. Okay, the half wave just now is just one diode, right? Okay, one diode, this one, okay, and then the perintang over here. Now, all you need to do is, instead of one diode, you use 4 diodes that are arranged in this manner. Okay, they are arranged in this manner. We're going to talk about this arrangement in a little while. Okay, dan ini memerlukan sedikit masalah. Okay, so the input AC current signal is still the same. Okay, it's still going to be up, down, like this. Okay, tapi apa yang kita harapkan is, after the full wave rectification, semua yang di bawah ini akan dinaikkan ke atas. Okay, so what's going to happen is you're going to have all this. Okay, and then after that, when it goes back, it's going to go this way, this way, this way, this way, this way, this way, and then up here, and then go back here. So you're always going to have the same current flow along the resistor or the light bulb. Okay, whichever one. Tengok arah di sini mungkin berlainan tau. Tapi selepas dia melalui diode, okay, jangan dulu salin ni. I will talk about this in a little while. Okay, but after it passes the set of diodes, it's going to be flowing in one direction. So the light bulb is always going to feel on, and the current is only flowing in one direction only. Okay, so every cycle, okay, notice the down yang sepatutnya kena off kalau half wave has already become on. Off will become on, off will become on. Okay, so the current flow will be from A to D1, okay, to X, flows to Y, to D3, okay. Yes, it can flow here lah if you want lah, okay, but it will flow back here also, no difference lah. Okay, but some of it will flow here and come out here. Okay, D3, and then go past to B. Okay, now the blue color line will be start from B, because the B is now positive. B goes to, it cannot come here, tidak boleh lalui sini kan, bila dia sampai di sini, it cannot come here because it is going to be blocked. So tidak boleh. So it has to flow here. Okay, and come to here, it cannot go here because it is being blocked. That's reverse bias. Okay, so it has to flow here. Flow here, flow here, flow here. Okay, kita ini lompat di atas wire lah. Okay, come up to here. Yes, it can flow here, but it will also flow here. And it can flow here, but it will also flow here, go all the way back to the negative side. Okay, so Let's talk about the direction of the current in the first half of the cycle. Okay, the direction of the current will be A to D1 to X, like I showed you just now, to Y, okay, to D3, and then back to B. Okay, manakala the second half of the cycle will be B, then to D2. Tidak boleh lalui sini sebab dia kena block oleh penghalang ini. So B to D2 to X to Y, come all the way here. When it comes to here, it's going to go to D4 and then go back to A. Okay, so the output signal will be this. Astaga, sorry. Okay, so this is the answer for this lah. A to D1 to X to Y to D3 to B. Okay, and then B to D2 to X to Y to D4 to A. Okay, now a very common question I get is, bila dia balik, okay, when it comes back here, let's say we're talking about the red color line now. Okay, let's say we're talking about the red color line. Okay, let's just consider the red color lines. Okay, so after it comes to here, okay, bila dia sampai, when current flows over here and it comes over here, dia memang tiada jalan lain lah. It must come to here. It cannot come to here because it's being stopped. Okay, boleh. Jalan, and then come to here. Now, kau tengok, it can go here, it can go here. Okay, I'm not saying that it is not going through here. Saya bukan cakap dia tidak melalui sini. It can flow here. Okay, dia boleh melalui sini, tapi because we want to complete the whole, I mean, you know, it goes over here and then go over here, then after that go over here again, and then go over here again. You know, it's going to be never ending lah. Kita mau kasih habis satu kitaran bah. Okay, so yes, I'm not saying that it cannot come here. It can, and some of it does, but some of it also flows here. Okay, and then sampai di sini, adakah some of it also goes here? Pun boleh. Okay, it will just contribute to this one lah. Okay, and it will come back. And then remember, when the current flows, right? Okay, because, well, this is actually in a parallel position, so the current will actually be split up. Okay, and that's totally fine. Tapi, takkanlah state the direction of the first half of the cycle, right? Okay, A to D1 to X to Y to, sampai di sini, okay, D4 lepas tu D1 lepas tu X to Y, and then sampai di sini, okay, D4 to D1. Come on lah, okay, please, everybody, cari cara balik kepada B. We want to start with A and we want to end with B. Second half of the cycle, we want to start with B, we want to end with A. Okay, so don't make things difficult for yourself. Cari cara yang tercepat untuk balik ke B lah. Okay, untuk kamu menulis perkara tersebut. So the same thing with the blue color lah. Okay, we always want, you know, B go back to A. Okay, walaupun I know that after it comes here, okay, dia boleh melalui sini dan dia boleh lagi balik ke sini tau. It can come back to here. I'm not saying it's not. Okay, I'm just saying that in order to go back to B, dia memang kena melalui sini. In order to go back to A, it has to also come here also lah. Okay, so the direction of the alternating current passing through the resistor R of each half of the cycle is the same. This is the most important thing. Okay, draw these two arrows and talk about this. Okay, because of the rectification done here. Okay, disebabkan ada pembetulan sudah dibuat di sini. Okay, the direction of the current that passes through the CRO, the resistor or the light bulb is always the same. That's why kalau kita pasang satu CRO di sini, we're going to get output like this. Output. So it's going to be turn on all the time. Kalau if I put the light bulb over here, dia akan nampak seperti turn on. But kalau kita lihat dengan mata kasar, it's going to be a little bit brighter, a little bit dimmer, a little bit brighter, a little bit dimmer lah. Okay, sebab the current is varying. Okay, and that's what we're going to be always seeing over here lah. Whether or not it is first cycle or the second cycle. Okay, the two directions are different. So a full wave rectification is a process where both halves of every cycle of an alternating current is made to flow in the same direction. Okay, so full wave, that means ini pun kena rectify, ini pun kena rectify. Remember the half wave rectification, only the top half is rectified. Okay, only the first cycle, okay, flows in the same direction. So there are many differences between the half wave and the full wave rectification. Okay, how many diodes are involved, the litar, okay, yang kena this one, sorry, the circuit, okay, of how it is drawn is also different. The definition is different, okay, and of course, you're talking about the flow of the current, lah, okay, is also different. Okay, but okay, so this is the same thing. Also more full wave rectification circuits. Okay, just to show you what it is like, lah. Okay, now there are several types of currents. This is in your textbook. Okay, a smooth direct current is essential for a circuit to function well. So this is alternating current, and this is an example of a direct current selepas kena rectify. Okay, this is already full wave rectification. But the problem with alternating current is this, the current that is flowing, dia makin besar, makin kecil, makin besar, makin kecil, makin besar, makin kecil. Okay, it is not as bad. Okay, dia tidaklah seteruk kalau half wave. Dia on off lah. Okay, it's very tiring. And on off. Kalau kamu dalam mentol, kamu pun akan mogok. Tapi in this case, it is better than a half wave rectification. But this is still the best. Steady direct current, just like a battery provides. Okay, so the question is, how do you convert, okay, an alternating current that has already been rectified fully to become a straight and steady direct current? Sebab ini pun at a very, like at a more molecular level, this is very tiring, after a while. Sebab dia makin kuat, makin lemah, makin kuat, makin lemah. Dia on. Okay, it is on. Okay, don't make the mistake. This is on all the time. Except that it is stronger, weaker, stronger, weaker, stronger, weaker, stronger, weaker. We don't want. We want this to be changed to strong all the way. So how do we do that? And this is where we add one more component which is called the capacitor. Okay, you studied capacitor when you were doing RBT last time. I don't know how many of you did RBT and how many of you did ASK. But if you did RBT, you would have learned a little bit about the capacitor. Okay, so a capacitor is a device that dia punya function adalah untuk menyimpan cas. Okay, dan bila dia menyah cas, when the circuit is off, it will discharge lah. Okay, so the function of a capacitor in the rectification circuit, okay, so a capacitor is used to smooth the current in a rectification circuit. Astaga. Okay, a capacitor is used to smooth the current in a rectification circuit because the half wave and full wave rectifications produce a direct current which is not smooth. Macam kamu cakap tadi lah, if this is a half wave, it's going to be on, off, on, off, on, off, on, off. So during the time where it is off, okay, the capacitor, what happens is, okay, let's talk about how the capacitor is used. So explain how a capacitor is used to smooth the current. When current flows through the R, okay, and the capacitor, because when current flows, okay, it's going to flow here, it's going to flow here. Sebahagian akan mengalir melalui capacitor dan sebahagian lagi melalui rintangan atau mentol atau TV atau whatever lah. Okay. Now, what happens is the capacitor starts charging. Dia akan menyimpan cas. Okay, the capacitor is charged up and stores energy. Now, because of that, when there is no current, when it is reverse bias, bila dia melalui sini, bahkan. Now, this is supposed to be reverse bias. Tidak kan? What is going to happen is the capacitor is going to discharge the charges. Okay? And make sure that there is some charge that is flowing through the resistor. Okay, so the energy from it is used to produce a voltage across a resistor. So dia macam tangki simpanan lah. Okay, if you want to think about it, a capacitor is like a tangki simpanan. Bila arus mengalir, okay, dia akan simpan cas. Bila arus berhenti mengalir, when it stops flowing, dia akan menggunakan dia punya reserve lah. Okay, to memastikan bahawa to ensure that the resistor over here always has charge flowing through it. Okay, but the problem is, since it is discharging, it's going to lose its charge lah. Okay, until this one. So yes, we won't get such a perfect direct current like this lah. But this, okay, current flow is like this, and then a little bit flat, and then up, and then a little bit. This is definitely better than this. Okay, on, off, on, off, on, off. It's very extreme. Okay, so we're going to get this kind of current flow. Okay, it's going to be like this, and then after that flat up. And it's going to berkurang secara beransuran lah. Okay, until the next cycle. So whenever the alternating current is a negative cycle, it will discharge. Once it is positive cycle, dia akan mencas balik. Okay, then negative cycle, it will discharge. And actually, if we take a look, the capacitor starts discharging the moment the current mula berkurang. Okay, this is much more deeper level lah. Okay, if you do electronics engineering next time, okay, you will learn this a little bit more lah. Ada masanya ini, there is a reason why there is a dotted line here and why there's a dotted line here. Okay, the capacitor only starts charging bila dia berhenti mendischarge. Okay, so why does this happen? You can talk about this when you go, if you do electronic engineering next time lah. But all we need to know is this, okay, that when during the negative cycle, okay, during the negative half cycle of the alternating current, the capacitor is doing its job. Okay, the capacitor charges, and the energy from it is used to produce a voltage across the resistor. And so if you have a light bulb over here, it's not going to be brighter, dimmer, it's going to be brighter and a little bit less bright, brighter, a little bit less bright, brighter, a little bit less bright, because the capacitor is trying its best to make it so that it's sentiasa bright. Okay, but on a full wave rectification, this happens even better lah. Okay, on a full wave rectification, you will see this. Okay, it is a lot smoother because dia punya tempo mendischarge is not so teruk lah. Okay, kalau half wave kan ini langsung tiada current mengalir. So it's going to be discharging a very long time. But in a full wave rectification, the period of discharging is very short. Sekejap saja dia discharge, charge balik. Discharge, charge balik. So it's going to be even more smooth compared to the half wave rectification. Okay, so the waveform produced, this one, okay, will be like this. It will be like this, like this, like this, like this. Much more smooth. Okay, but of course not okay, not like this lah. Okay, dia bukan totally smooth all the way lah. Okay, that one, unfortunately, that can't happen. Well, unfortunately, that can't happen lah. Maybe next time when you do electronic engineering, you will be the one to discover lah. Okay, how to make it like super smooth. Okay, what other component you need to add. But for now, the best thing that we can do is we put a capacitor and it becomes kind of smooth. So the current flow is like this. So it's a little bit, like bumpy along the way lah. Definitely better than this. Okay, this is, much more worse than this lah. Of course, the worst is this lah. Okay, ini paling teruk. It's to be on, off, on, off, on, off. Okay, let's watch a couple of videos to see.
Okay, jadi cikgu buka external masa. Okay. Ini kita direct kan?
Okay, this is direct current. No, alternating current, sorry. So, the one that you saw just now, okay, is the alternating current. Positive, negative cycles. The next video. Okay.
Alright, so kita nampak dah.
So this is a half-wave rectification.
Ada kan?
Okay.
So maknanya yang atas tu ialah simpak pincang ke depan. Yang tak ada tu ialah pincang. Okay, so kita ada apa? Arus balik, diode dan juga apa? Sel kemudian. Okay, sekarang ni kita nak tekan pakai kapasitor pula. Apa jadi? Okay, tekan kapasitor ni, kapasitor. Ni kapasitor kan? Okay, cikgu onkan dia. Tengok, ikut dia. Dia dah rata kan? So ni kita panggil perataan arus. Okay, alright.
Okay, so what you see over there is that it's even more flat lah than apa yang kita, kita the one that we draw just now over here. Sorry, the one that we drew just now over here. Okay, but actually it looks very flat. Kan on the screen that you saw just now, it looks very flat, but actually this is what it is lah. Okay, kalau saya ubah skala, if I change the scale on the display just now, you will probably see something like this. Okay, so now let's look at another one. Oh no. Okay. This is alternating current, I think. Yeah. Okay, take a look at the diodes. They are arranged this way. Okay, this is a capacitor. Okay, of course, this is a switch to turn on to enable the capacitor lah. Okay, but when the full wave rectification is happening, okay, okay, so you're gonna kind of see this kind of pattern. Okay, it's not very helpful. Actually, it's just up all the way lah. Okay, but I think the point of this video is just to show you. Take a look at the diodes. Okay, in a full wave rectification. Okay. Yeah, sorry. This is a capacitor, this is diode, this is a perintang lah. If you saw the half wave just now, let me see. Where's the half wave? Okay. Look at the half wave one. It's only one single diode. Okay, one single diode. Okay, and then the resistor over here. And then of course the capacitor, if you turn it on, then it will flatten the curve lah. Okay. All right. Do you know what this means? This means that we are done. Okay, we are done and we can go into the tutorial lah. Let's start from the back. Okay, we start from the back lah, because the back usually has the heavier stuff, right? Okay, so what is meant by a semiconductor? This is a very standard one. Okay, a semiconductor is a material which has a conductivity or resistance between an insulator and a conductor. Okay, antara satu pengalir dan penebat. Okay, you can talk about the conductivity or the resistance. It's the same thing. Okay, but as long as you know what is the definition of a semiconductor lah. Okay, since this is relate the lighting of the bulbs, the current, and the way the diode is connected to the terminals of the battery to deduce relevant physics concepts. So this is kind of like a comparing question. Okay, but it is dia tidak suruh kamu compare lah, dia suruh kamu terus relate. Okay, so this is how this would be. So the first mark will be the bulb in 10.1 does not light up, but the bulb in 10.2 lights up. Okay, so no matter what, you still have to compare lah. Okay, you still have to compare. Okay, 10.1 dia lights up, 10.2 10.1 does not light up, 10.2 it lights up. Okay, except that we don't say, the lighting up is bigger than the not lighting up. We can't use the words bigger, greater, all this here lah. Okay, now in 10.1, there is no current flow. Okay, manakala in 10.2, there is current flow lah. Okay, and the reason for this is because if you take a look at this, in 10.1, the positive terminal is connected to the N semiconductor, which is the cathode. Okay, so the positive terminal is connected to the N-type semiconductor or is in reverse bias. Okay, mana-mana satu, okay, will give you the full mark. Of course, the words reverse bias is much easier. Okay, much easier to explain. But if you want to write fully, okay, it also not a problem lah. Okay, and you write the same thing but in opposite for 10.2. 10.2 is forward bias. Okay, so the concept that we're talking about here is that when a diode is forward bias, current flows and bulb lights up. Okay, so this is in other chapters we call, what we call this, like we call the compare and then kasih relationship, bukan? Okay, but for electronics lah, okay, especially we find that it's difficult to do a comparison question because they're either pasang atau tidak pasang. They're either on or off. Okay, so it is the same concept except that the way we answer it is a little bit different. Okay, so I guess it's a good thing that we are answering this. Okay, so that we can learn lah. Okay, electronic kita kena berhati-hati sikit. Okay, we only talk about forward bias, reverse bias. Forward bias macam mana, reverse bias macam mana. Keep it simple. Okay, moving on. All right, so this is a Fullback rectification circuit. Okay, draw the waveform. So this will be the waveform. Okay, and then of course, a capacitor is placed across the output to smooth the current. Draw the waveform produced. So we want this lah. Okay, I want to see this waveform. Dia akan menaik dahulu. It's going to go up first. It's going to go up first. And then after that, it's going to start discharging. So go up, discharge, and then go up a little bit, and then discharge, and then go up a little bit, discharge, go up a little bit, discharge. So a little bit more smoother. You don't have to draw this bottom part if you don't want to. Okay, you just have to draw the things that are marked out in red lah, and then explain. Okay, so the explanation actually is given in your notes, but you can copy this also if you want. When the current flow is forward bias, okay, or when it is forward bias, the capacitor stores energy. Dia akan menyimpan charge. When it is reverse bias, it discharges. Okay, it discharges atau akan membebaskan elektron lah, yang menyebabkan arus mengalir. Okay, but the simplest explanation to this, I'm trying to keep this as simple as possible because last week, it was so bad. So we keep this as simple as possible. Okay, forward bias, it will charge. Reverse bias, it will discharge. Okay, dia akan melepaskan charge dia to make sure that the resistor always has current flowing in it. Okay, important. Capacitor is very important. Okay, as a current smoother. Okay, perata arus in Malay it's called perata arus lah. Okay, but the function of the this one is to smoothing the current. Smooth the current. Yeah, to smooth the current lah. Okay, is the function of the capacitor. Okay, let's go to question number 4. Okay, semiconductor, this one. So what is the meaning of semiconductor? The same thing. Okay, material, yada yada. What happens to the light bulb when the switch S is turned on? Okay, when the switch S is turned on, let's take a look. The dry cell here is positive and here is negative because this leg is longer. Okay, so it's going to flow over here. So obviously this is forward bias. So the current is going to flow and the bulb will light up. Okay. So the diode is connected to a cathode ray oscilloscope with different supplies. Okay, take a look at this. Take a look at how the biasness is. Okay, but this is alternating current. So diagram 3.31 shows the diode connected to AC, time base. Sketch the waveform displayed on the CRO in this one and in this one. Okay, let's first talk about this. Okay, this is a direct current. Okay, because it's a battery. So here is positive, here is negative. It's going to flow and it's going to come up to here, which is a negative. So this is reverse bias, right? Reverse bias means no current flow. And the current is only going to be able to flow one way because this is a battery. So memang current hanya akan melalui sini saja. But it can't flow any further because it is stopped by the diode. So what you're going to get is, you're going to get no current flow. Okay, totally zero, like this, flat. Okay, zero current flow. Right? Now, in an alternating current, okay, alternating current we know lah, okay, because this is a half-wave rectification circuit. So you're going to get on, off, on, off, on, off, on, off. Okay, pretty simple lah. Actually, not that difficult. We just have to know reverse bias ke forward bias. Itu je. Okay, is it reverse bias? Is it forward bias? Forward bias, current flow. Reverse bias, current don't flow. All right. Now, question D. Name component S. Okay, so obviously component S is a diode lah. Okay, and then explain how component S is used to produce a half-wave rectification. Okay, so you can talk about this lah. During the first half of the cycle, the diode is forward bias. Current flows through the resistor. Okay, so 1 mark, 1 mark. During the second half of the cycle, the diode is reverse bias. Current does not flow through the resistor. 1 mark. Okay. So explanations in this particular subtopic, okay, rectification, keep the explanations simple. Okay, jangan libatkan Okay, I know I talked about the depletion layer and everything, but that is just to help us to understand how the diode functions. But when we talk about rectification circuit, keep the explanations simple. Okay, jangan menyusahkan diri, ingat je. Forward bias, current flow, 2 marks. Reverse bias, current doesn't flow, 2 marks. Okay, keep it simple. Okay, because it does not have to be that difficult lah. Unless lah, okay, unless, okay, Sekejap, siapa yang buat paper 2 for your trials? Oh, it's not me. Sorry, I'm doing paper 1 for trial. Am I doing? Yeah, I'm doing the paper 1 paper for trial. So, okay, so good luck. So, for the rectification circuit lah, okay, unless the question asks you to explain why the forward bias happens, okay, jangan libatkan the depletion layer, the junction voltage, the N, the P, the electrons jumping over. Don't involve that. Okay, keep it simple. Forward bias, current flow. Reverse bias, no current flow. Okay. All right, let's go to question number 3. Is this question number 3? Yeah. I wonder how many questions we can do before I finally stop. Right, diagram 6.1, 6.2 show 2 circuits with identical components. Each circuit contains an emitter, a cell, and a semiconductor diode. Give one example of a semiconductor material. Okay, and I don't know why this one comes out a little bit later. Hold on, let's skip this question first. Let's go to this. Observe diagram 6.1 and 6.2. Okay, state the difference between the connection of the diodes. Okay, now remember guys, when you see the words connection of the diodes, there are only 2 types of answers. Either it is reverse bias or either it is forward bias. And you can clearly see, okay, that here there is no current flow because here positive sambung kepada negative. So it is reverse bias. So 6.2 is forward bias. Okay. Then state the difference. Okay, state the difference between the reading of the emitters. Okay, 6.1 the emitter reading is 0. 6.2 the emitter shows a reading. You don't have to say 2.7 according to my very sharp eyes. It looks like 2.7. No need. Just say 6.2 emitter shows a reading. Question is asking for state the difference, not compare. Okay, so you cannot say 6.1 is smaller than 6.2 because it's not asking you to compare. It's asking for a difference. Okay, so state the difference. This is 0, very clearly 0. This one shows some reading. Okay, so give 2 reasons that cause the difference between the reading of the emitters. Oh, sorry, let's go back to question A. Silicon and germanium are the two most common semiconductors. Okay, so give 2 reasons. Give 2 reasons that cause the difference between the reading of the emitters in diagram 6.1, 6.2. Okay, number 1, because in 6.1 there is no current flow. Duh. Okay, and in 6.2 there is no current. There is current flow. Okay, and the second possible reason, and this is where you finally bring in the depletion layer. Okay, but if you until now if you don't understand the depletion layer, just remember lah. Okay, forward bias reduces the resistance in the diode. Okay, reverse bias increases the resistance in the diode. Okay, so ini yang menyebabkan the current to flow because smaller resistance, current bigger mah. Okay, so when you arrange it reverse bias, you actually increase the resistance so that current cannot flow. This is a very important thing that we will talk about in the next subtopic, which is tomorrow lah. Okay, but we need to think about this. In reverse bias, resistance is bigger. So when resistance is big, current is small and current cannot flow because it's too big to allow the current to flow. In a forward bias, okay, depletion layer menjadi kecil, blah, 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 but the resistance becomes smaller. Resistance becomes smaller, so current is able to flow. So tidak banyak rintangan di sana. Okay, I want you to start this statement lah. Okay, it's very important. High resistance in diagram 6.1. Or if you don't want to start this statement, at least remember that when we're talking about reverse bias, we're talking about high resistance situation. Okay, when the resistance is high, there is not enough current that's going to be able to flow. In a forward bias situation, the resistance is much less. Okay, so current senang mengalir apabila rintangan adalah kecil. Okay, now based on the answers in 6B and 6C, what is the function of the diodes in this circuit? Even if you don't look at 6B and 6C, you will know that the function is to allow the current to move in one direction only. Remember, people, if it is not a rectification circuit, okay, then this is the answer. If it is a rectification circuit, the function of the diode is to convert alternating current to direct current. Okay, but this is not a rectification circuit. Okay, this is just a circuit to show forward bias and reverse bias. So the function of the diode is to allow the current to move in one direction only. Okay, so be aware of the differences in the function of the diodes. Okay, last question. Do I even need to do this? Okay, this is a rectification circuit. So since this is 2 marks, you're talking about the 2 cycles lah. Okay, so the diode converts in the first half cycle, diode is forward bias, current flow. Second half cycle, diode is reverse bias, no current flow. Kau tim. Okay, same explanation now all the way, whether it is 2 marks lah, 4 marks lah. Okay, this is just very sad lah because you write so much and it's only 2 marks. Just now the one that we answer, you write so much, you get 4 marks free. But it is the same explanation. First half cycle, forward bias, current flow. Second half cycle, reverse bias, no current flow. Okay, for the past 1 hour, I've been talking the same words. I think I have said forward bias and reverse bias more times than I have said, okay, so, which is the usual words that I always say. And I don't know whether any of you are still keeping count of berapa kali saya cakap okay dan so dalam satu kelas. Okay, so if you're keeping count, please let me know what is my record so far so that I can know what is this one. Okay, so yeah. Okay, the thing is this lah. First half cycle, forward bias, current flow. Second half cycle, reverse bias, no current flow. Okay, so for your homework for this one, please finish all the tutorials until question number 2. Okay, so all 12 objective questions plus question number 2 and hand it in to me by next Tuesday. Yes, before next Tuesday. Those of you who haven't finished the first subtopic punya tutorial, okay, the deadline was yesterday lah. So I'm like wondering, what are you waiting for? Are you waiting for something to happen before something happens? Okay, but for this one, because tomorrow saya baru mau mula subtopic ketiga, so it's just going to be a lecture. So finish this tutorial latest by next Tuesday and send it to me as a PDF in your homework Telegram channel. All right.